Okay, in this video we're looking at the final exam solutions and Chem 262 for the year 2017. Just kidding, we're actually looking at the use of esters in cake baking. This presentation is brought to you by myself, Abid, and my partners Nicole, Henry, and Emily. So now let's just get the show on the road. I'll be taking care of the introduction, the inspiration for our topic, and some brief general applications. Henry will take it from there and discuss the structure, characteristics of the ester, and go into deeper detail about the mechanism that produces the ester. Emily will go into great depth, showing you further applications of esters in ice cream and chocolate. And Nicole will finish things off with the analysis of esters in the baking world, and even show a real-life organic chemistry example of one cake she baked with an ester, and one cake without one. Obviously, as much as it scares a lot of people, organic chemistry is literally everywhere. The pills that you take when you're sick, the color that you see in your shirt, and even the smell and taste of food. Before I proceed any further, I wanted to show to you the inspiration for our topic. Right before spring break, our first topic, polymers, was rejected. So it was back to square one. However, during break, I bought a tres leche caramel cake from Costco. Before devouring it, I looked at the ingredients, and I saw something that caught my eye. It said polyglycerol esters. So I did some Googling around, and I said to myself, aha, voila, I knew this would be the right topic. Whether you believe it or not, there is organic chemistry present in cake baking. Now, could you guess how specifically esters are used in cake baking? I'm going to give you 5 seconds to think about it. Boom, time's up. I don't know if you would have been able to guess it, but polyglycerol esters are used as emulsifiers, which binds with water, making the cake moist. As you can see in the pictures below, the one on the left shows a very dry cake. This obviously has no ester. Now the middle one has the ester and is very glossy and moist. In fact, just looking at it makes me hungry. Now, it's hard to see in the third picture, as it's from a research paper, but the left half of the cake was baked specifically without an ester. It looks very dry and has tons of holes in it. Now if you look at the right hand side of it, or the right half, it contains an ester and it looks very full. Notice the difference in the third picture? If you don't worry about it. You'll definitely see it later in this presentation.
Alright, the specific ester used in cake and chocolate making is polyglycerol polyricinoleate, or PGPR for short. This compound is made up of a combination of glycerol chains paired with ricinoleate chains. The glycerol portion is hydrophilic, while the ricinoleate portion is hydrophobic. This combination creates a molecular boundary between oil and water layers, and as a result can improve the moisture retention in baked goods and keep them from drying out. Shown are examples of triglycerol and triricinoleate. Some of the characteristics of PGPR include an amber-brown color with a soft and waxy texture. PGPR's most important characteristic is that it is a very strong emulsifier, which stabilizes systems that contain low fat and high water concentrations. It also affects the viscosity of the mixtures that it binds with, lowering the frictional forces between the water and fat molecules, improving the flow rates. As a result, PGPR is heavily used in baking and in other products that include fatty oil and water mixtures. The synthesis of PGPR is a three-step process. Firstly, glycerol is heated to over 200 degrees Celsius with a metal catalyst to form polyglycerols. In the second step, castor oil fatty acids are heated similarly and undergo an esterification process to form the ricinoleate fatty acids. In the final step, the interesterified ricinoleic fatty acids are mixed with the polyglycerols to form polyglycerol polyricinoleate chains of varying lengths. Shown here is the condensed version of the reaction, showing the formation of a glycerol chain and then combined with a single ricinoleate chain to form a triglycerol triricinoleate molecule, a common version of PGPR.
In cosmetics, esters are incorporated in hairstyling gels, skin treatment gels, skin cleansers, baby creams, long-acting hand creams, moisturizing sunscreens, and sun protective sticks. The ester controls the viscosity of these products. For example, cholesterol isosteric is used in lotions and provides the oil base for certain lotions, which is good on your skin. Another example is isopropyl palmitate, which is used in shampoos and gives the shampoo a low viscosity, and it is also good on your skin. The best emulsifiers are diglycerol diisostarate, which is used in foundation creams, diglycerol monolaurate, which is used in makeup removers, and diglycerol monoleate, which is used in baby creams. Esters are also found in fragrances. They give perfumes and colognes their distinct aromas, such as banana, apple, or wintergreen. Esters can also be found in chocolate. For example, polyglycerol polyricinoleate is an emulsifier made from castor beans, which reduces the viscosity of chocolate. It has lower costs because it uses less cocoa butter and has less fat. Sucrose esters also reduce chocolate stickiness for easy shaping. As you can see, the photo on the left shows perfectly formed roses, while the photo on the right has chocolate that is falling apart and is very sticky. Esters also help prevent crystallization of cocoa butter or sugar, they improve the smoothness of the chocolate, and they improve heat resistance to avoid oil from separating. They also improve taste because it weakens the strong bitter taste of chocolate. Esters in ice cream give the ice cream its light, delicate taste. It also promotes volume expansion, reduces freezing time, prevents excessive crystal growth, supports uniformity, and increases its resistance to melt. The sucrose esters are mixed with colloidal microcrystalline cellulose, which significantly enhances foam stability and anti-melting capacity of ice cream. In the picture, you can see that without the emulsifier, the ice cream will not hold its shape and will simply melt. In dairy products, esters help to stabilize and disperse milk fats and prevent stratification. They also help avoid browning, they provide the thin taste that skim milk has, and for milk powder products, it helps increase their water solubility and increase dissolution. It also helps avoid bubbles in yogurt. As you can see from the top photo, there is not enough ester, whereas in the bottom photo, the ester is doing its job. It is best to mix sucrose esters with monoglycerides and use it with microcrystalline cellulose, carrageenan, pectin, PGA, and other thickeners to achieve the best results in dairy products. For meat, esters help to increase water retention to keep the meat fresh. It helps avoid shrinkage and oil loss for sausage, ham, fish sausage, and canned meat. It improves tenderness and taste, reduces costs, and makes casings easier to peel off the meat. It is best to blend sucrose esters with monoglycerides and lecithin to form compound emulsifiers that can then be mixed with the meat and other ingredients. For fresh meat, it is best to soak it in the ester to keep it fresh. Sucrose esters are green products, meaning they come from natural sources. They are easily digested and absorbed and can replace magnesium stearate and other harmful food processing additives. They also help digestion and improve metabolism.
Polyglycerol esters are widely used in the baking world. A few functions include acting as dough conditioners and crumb softeners. The ester works as a dough conditioner by binding the gluten proteins together into strands. The gluten proteins are activated when the emulsifier is added. The activated proteins have more binding sites on them, which enable them to form disulfide bonds with each other. This structure, from gluten proteins to gluten strands with disulfide bonds, is shown. Using an ester for a dough conditioner has several benefits, including being able to compensate for low flour quality, dough that tears less easily, and improved texture of the final product. Emulsifiers have commonly been referred to as crumb softeners. However, this term is incorrect. It was believed that these crumb softeners made bread softer through distributing water more, when actually the ester interferes with the recrystallization of amylose. Amylose is a polysaccharide found in starch. The structure of amylose consists of glucose monomers in a helical shape. Interfering with the recrystallization of amylose slows down the fermenting rate, or in other words, slows down the bread from becoming stale. Shown here is an example of a cake made with polyglycerol esters and a cake made without polyglycerol esters. As most cake recipes include some kind of emulsifier, for example, eggs are a type of emulsifier, it was a little difficult to bake a cake without one. However, it simply came down to making a cake from scratch and substituting out the ingredients that function as emulsifiers. On the left is shown the cake without the ester, and on the right is the cake with the ester. It is easily shown that after all ingredients have been mixed together, the cake batter with the ester is much more moist. This is due to the polyglycerol ester binding to water. The cake without the ester also crumbled a large amount when cut into and when a slice was taken. Overall, the quality of the cake made with polyglycerol ester is higher. Therefore, polyglycerol esters are widely used in baking to enhance the quality of the final product made.